Good morning students, welcome to video lecturing class. So today we will continue with the problems. So here is the given problem. So we need to find out C of S and by R of S, that is we need to find out the transfer function for the given signal flow graph. So the very first step is we need to identify the number of forward paths. So there are two forward paths. First one is 1, 50, 12, 1 and 1. Then the second one is 1, 50, 12, 1, 11, 2.5 and 1. So here forward path means all the signals should be in forward direction, like that you have to check. So here we are having two forward paths. Then you need to identify the number of loops, feedback loops and their gains. So the first one is, let's start from this node, 12 and minus 1 is 1. And 1 and minus 2 second loop. Third one is 50, 12, 1 and minus 1. Then fourth one is, if I start from here, 11, 2.5 and minus 1. And fifth one is from here to coming back to the origin, that is it is a self loop, and their respective gains are we need to calculate, because here he has given gain in terms of numbers. Then you need to identify two non-touching loops. So here if you see this SFG, our L1 is this one and L2 is this one, that means they are sharing a common node here. So L1 and L2 combination is not a non-touching loop combination. If I take this L1 and L3, L3 is again it is sharing a common node. If I take L1 and L4, they are not sharing any common node, so I can take that combination as two non-touching loops. Then moving further, your L1 is here and your L5 is here. So again these two are not sharing any common node, so I can take L1 and L5 as the non-touching loop pair. Then if I take this L2 is here and your L5 is a self loop. So again they also don't have any common loop, so we can say that they are having the two non-touching loops. So then you need to write the equation for delta. Delta is equal to 1 minus summation of gain of all individual loops. There are 5 loops, so L1 plus L2 plus L3 plus L4 plus L5 plus summation of product of the two non-touching pairs. So there are 3 pairs, so L1 L4 plus L1 L5 plus L2 L5, and you know their values. Substitute and you will get the delta as 965. Then you need to find out the delta 1 and the delta 2, because number of forward path is 2 here, so you need to find out two deltas. So first for T1 you have to check for the non-touching loops. If you consider T1, only L5 is non-touching, that is your T1 is this. Remaining all, that is L1 to L4 are having any one of the node on the forward path, but your L5 is here, so it is non-touching to the first forward path. So except L5 you have to eliminate all the terms in delta. So you left with the delta 1 as 1 minus L5, that is 0.5. Similarly for T2, L1 is non-touching, that is your T2 is starting from this R 1, 11, 2.5 and 1. So your L1 is here, so only L1 is don't have any common node on the first forward path, but remaining all the loops are having or sharing a common node, so we can eliminate remaining terms except L1 in the delta equation. So left with the delta 2 equal to 1 minus L1. So here we cannot eliminate only L1. Once if L1 becomes 0, so this product will also become 0. Therefore only this L1 is remaining. So 1 minus L1 is the delta 2, whose value is 0.3. And we know C of S by R of S is T1 into delta 1 plus T2 into delta 2 divided by delta. So if you substitute the values, you will get the transfer function as 0.6813. Then moving further, the second problem for today's session. By using Monson gain formula, you need to identify the transfer function. So first you need to identify the number of forward paths. So if I start from here, G1, G5 G6, G7, G8. Then it is G1, G2, G3, G4 and G8. Then check for the any other combination. If I start from here G1, G5, I cannot go in this direction because the direction of the signal is opposite. Similarly, here also it is opposite. So number of odd paths are 2 and their gain values. Then you need to find out the number of loops. So first, if I start from here, it is G3 and minus H3, G6 and minus H6. So only there are 2 loops. If you check for any other combination, if I start from here G3, G4, I cannot go in this direction because the signal is in opposite direction. So there are only 2 loops. Both, if you consider the number of non-touching loops, your L1 is here and your L2 is here. They are not sharing any common node, so you can take that combination as the non-touching loops combination. Then you need to write the equation for delta. Delta equal to 1 minus L1 plus L2 plus L1 into L2. Then for T1, if you take your T1 as this one, G1, G2, G3, G4, G8. This L2 is not sharing any common node, so you can accept that L2. You have to eliminate all the terms in delta. So eliminating L1. Similarly for T2, L1 is non-touching, so your delta 2 will be 1 minus L1. So substitute the values in C of S by R of S is T1 into delta 1 plus T2 into delta 2 divided by delta. So this is the transfer function. Then similarly, the next one is similar, only difference is here you are having 2 more signals. Because of that, your number of odd paths will increase. So first one is start from here 1, G1, G2, G3 and 1. Then second one is 1, G4, G5, G6 and 1. Then third one is 1, G1, G7, G6 and 1. And the fourth one is 1, G4, G5, G8, G3 and 1. Okay. Then fifth one is G4, that is 1, G4, G8 minus H2, G7, G6 and 1. Similarly, G1, G7 minus H1, G8, G3 and 1. So there are 6 forward paths. Then you need to identify the number of feedback loops and their gains. So as similar to the previous, so this is one loop, that is G2 into minus H2 and G5 into minus H1. Then there is one more loop, that is if I start from here, is G7 minus H1, G8 and minus H2. So that is also one more loop. So there are 3 loops. Then you need to identify 2 non-touching loops. Since L1 and L2 are making the combination of non-touching loops, L1 and L2 are the non-touching combination. So if you write the equation for delta, it will be 1 minus L1 plus L2 plus L3 plus L1 into L2. So now you need to find out the values of delta 1, delta 2, delta 3, delta 4 and delta 5, delta 6, because there are 6 forward paths. So if you consider the first forward path, only L1 is non-touching, so except L1, eliminate all the terms in delta, that is 1 minus L1 equal to 1 plus G5 into H1. Similarly, for T2, L2 is non-touching. Then if you take the paths from T3 to T6, they are touching all the forward paths, so you have to eliminate all the loops from the delta value, whose value is going to be equal to 1. So from delta 3 to delta 6, the value is 1. So we have to write C of S by R of S as T1 into delta 1 plus T2 into delta 2 plus T3 into delta 3, likewise plus T6 into delta 6 divided by delta, and substitute the respective their values, gain values, they will get the transfer function. Then determine overall transfer function for the given signal flow graph. So here also number of forward paths are 2, that is G1, G2, G3, and the second forward path is 1, G4 and 1. Okay. Then number of loops, there are two self loops, minus h1 minus h2, and if I start from here g3 into minus h4, and if I start from here g2 g3 and minus x3. So there are 4 loops. So now you need to find out combination of two non-touching loops. So L1 and L2 are the self loop and they are not sharing any common node. So L1 into L2, and L1 is here, your L3 is here, so you can take that combination also as non-touching loop. Then delta equal to 1 minus L1 plus L2 plus L3 plus L4 plus summation of, that is L1 into L2 plus L1 into L3. Now if you take the first forward path, all the loops are touching the first forward path, that is your first forward path is this one. And if you consider these 4 loops, they are having a common node on first forward path, so you have to eliminate all the loops to determine the value of delta 1. Then if you take second forward path, L1 and L2 are non-touching because your L1 is here, L2 is here. Your second forward path is this one from here to here, but this L3 is having a node here and L4 is also having a node here, so they are touching. You have to eliminate L3 and L4 from delta to get the value of delta 2. Then you have to write C of S by R of S by T1 into delta 1 plus T2 into delta 2 divided by delta. Substitute their respective values, you will get the transfer function. Then moving further, here instead of giving you the signal flow graph, he will give you the block diagram and he will ask you to convert that block diagram into signal flow graph first. Then he will ask you to determine the transfer function. So here, to represent the block diagram into signal flow graph, you have to represent each summing point and takeoff point by a separate node. That is, starting point R is there. So here where I am having a summing point, so one node. Then here I am having a takeoff point G2, sorry, another node. Then here I am having one more summing point, so that summing point will come here. So this is for this, and this one is for the takeoff point, and this one is for the this summing point. And in the feedback loop, so here it is having h1 and you are having one summing point here. So from here to here one node, then it is fed to h2 as h2. Then from here it is a g4 is coming with a negative sign, so minus g4. So and while writing their gain values, you have to look into their fed signal. So here this g4 is fed with minus sign, so I am taking it as minus. Then you need to find out the number of forward paths. So the first forward path is 1 1 g1 g2 and 1. Second one is 1 1 g1 g3 and 1. 1 g4 h2 g1 g2 and 1. Then 1 g4 h2 g1 g3 and 1. Okay, so there are 4 forward paths, and number of feedback loops, if you take the number of feedback loops, it is g2, sorry, start from g1 g2 minus h1 and minus h2, sorry, plus h1 and minus h2. The second loop is g1 g3 1 h1 and h2. So there are only 2 loops. Then you need to identify the non-touching loops. So your L1 is here and your L2 is also here, so that means they are sharing a common node, so we can say that no two non-touching loop combination. Then delta is equal to 1 minus L1 plus L2. And if you take, or if you consider the forward paths, all the forward paths are touching, sorry, all the loops are touching all the forward paths, because your forward paths are having G1. In all the forward paths you are having G1, and in all the loops you are having G1, that is this node. So that means you have to eliminate all the L terms from the delta. So your delta k value will be, that is delta 1 to delta 4 will be equal to 1. So C by R, that is output by input, will be T1 into delta 1 plus T2 into delta 2 plus T3 into delta 3 plus T4 into delta 4 divided by delta. In their respective value you have to write, that is G1 into G2 plus G1 into G3 plus G1 G2 G4 H2 plus G1 G3 G4 H2 divided by the delta value will be 1 plus G1 G2 H1 H2 plus G1 G3 H1 H2 is the transfer function. So here the only thing is to be able to identify the number of power paths, number of feedback loops, and number of 2 non-touching loops and 3 non-touching loops. And you should know that Munson-Gear formula, that is this one, and you know how to write the delta equation. So you should be able to write this Munson-Gear formula, and you should be able to identify the delta 1, delta 2, delta 3, those equations. So these deltas values depends upon the number of order paths. Okay. So with this we'll wind up the second module. So in the second module we have discussed the two bits. That is, first one is mathematical modeling of the physical systems, under which we have derived the equations for the transfer function for the mechanical systems, electrical system, pneumatic and hydraulic systems, and we have also studied the analogous system, that is conversion of mechanical system into electrical system by using FV analogy and FI analogy. And then we have started with the block diagram reduction. There are 10 rules you need to remember to identify or to determine the transfer function for the given block diagram. Then the signal flow graphs. So the first bit is mathematical modeling of physical systems, and second bit is block diagrams and signal flow graphs. So this is the end of the second module. If you have any doubt or any queries regarding this block diagram reduction or signal flow graphs or mathematical modeling, you can leave a comment in a comment box, or you can call me for any doubt. Okay, thank you.